does the HP Z840 Workstation require Z coolers? That's a good question. Now these feature the 3D vapor chamber. They're also designed for really fast heat dissipation. Beautiful staggered hex fin arrangement fully helps with that purpose. Also reduces noise and increases surface area. We've got a very large machine base plate compared to the stock coolers, and that improves our CPU contact, as well as heat dissipation. Now the question is, do you need them? Or could you get away with the stock coolers? How effective are they exactly? Or how do they compare with, say, the stock cooler? Well, you're asking the right questions. Those are the exact questions I had walking into this. So what is the difference between them? Well, let's do a test. What is our machine? Well, none other than the Z840 Workstation. Let's have a quick nosy around. We've got our Aorus NVMe adapter down the bottom. Got the RTX 3080. This particular one is the Asus Strix, very capable 12GB model. There's our 3 power cables, critical to allow this GPU to fit this particular machine. And we also have our NVMe. The NVMe there has now been updated. Whoa. Okay, is it getting hot in here? Is it just me? No, it's definitely getting hot in here. You guys feeling that heat? Wow. I wonder where all this heat's coming from. Whoa, wow, it's smoky in here. What's all this? Okay, I didn't expect that. Why is there so much heat and so much smoke? Ah, that's right, we're here to replace these coolers. Well, now it makes more sense. Look at them. Now, a fair bit of dust there. This machine does work really hard producing content. There's our 3D vapor cooler. Let's do a quick switch. They do look good. Let's do a side by side there. Yeah, that does look really good. So let's get going. First things first, we need our tools. What do we need? Well, a very specific set of tools here. Screwdriver, and in particular, we're looking for that T15. There it is there. Let's lock and load and work our way through. So very simple, 4 screws on each of these coolers. Now, I'd highly recommend that you do this in a crisscross pattern. Helps to alleviate the pressure placed upon the CPU in an even and consistent manner. If you just release one corner, you're going to create an imbalance. So check, that's my recommendation. There are other variants of it, but that's a pretty good guide there. Pause on that if you need to have a look. Now, what thermal paste do we have on here? Well, this was Arctic Silver 5. You'll see the comparison there, 5 months of use and 2.5 years worth of use. You'll see a little bit of the pump out effect on the edges, but so far that's still looking pretty reasonable for the time period they were in. So why am I upgrading? Why am I replacing these, especially when I only just installed new CPUs? Well, the main reason is thermals. Now, doing a quick comparison between these, you're going to notice a rather striking difference in the design elements between these two CPUs, or rather the CPU coolers. Let's do it. We got our thermal paste. You guys can make your choice there. We have 3 excellent selections and then another Cooler Master. Not to say that's not excellent, but we'll go with Arctic Silver 5. That is the brand that I guess I'm endorsing here. Cooler Master Gel Pro might be worth a try or do some testing at some point, but for now, still sticking with the tried and tested. Now, a quick spray here. So make sure not to get this in your eyes. It can cause a lot of damage. Oh, yep, no, you don't want to do that. That will cause damage. Okay, there it is. Grabbing our towel. Let's quickly clean off the existing thermal paste. Now, technically, this thermal paste would absolutely have been able to do a lot of extra hours, but for now, it's okay. We will replace this in the name of science. We want a fair test, brand new thermal paste. Let's see how the Z coolers will perform. Okay, quick tidy up there. Now, hopefully no strange things here. We just want this cooler to be nice, or rather the CPU to be nice and sparkly. Now, take your time on the cleaning. Some thermal pastes are thermally and electrically conductive, so you got to be careful. If you do manage to spill a little bit of the thermal paste, very important to remove it. And right now I'm using a ultra rare one of one device. No, that's not just an ice cream stick, it's specially made for this purpose. And it's really useful because we can get into those corners. It's not going to conduct any electricity and cause problems, although naturally the machine will be disconnected while you're doing this. But very important, scope out your thermal paste. Make sure that it's not electrically conductive. It's okay if it is, it just means you have to be extra cautious. So we'll try and remove this a little bit. Obviously dropped off at some point. Really not a fan of having thermal paste swimming around. So let's see if we can tidy this up just quickly. Now, Arctic Silver isn't, electrically conductive, definitely thermally conductive, but that does give us the benefit here of not having to worry quite as much, but still, you don't want to get your thermal paste all within your components. Never a good idea. Now we'll zoom in a little bit here. Lovely, can't see a single thing, but you guys get the idea. Gentle does it, and I'm just gonna rush that a little bit. We'll call that fixed. Okay, let's reinstall the CPU bracket here. If you do want any further details on the installation process, could be well worth checking out my previous video for the installation of the CPUs. Well worth the watch, lots of detail on how to do that process. Okay, this is delicate. I think that's going to have to do. Really, really difficult to get all of that paste, but we'll call it. That's close enough. Don't judge me for it. Now, making sure that's still seated well. If it wasn't, you're going to hear lots of crunching noises, which is not a good sign. So for now, that's looking excellent, and we shall continue with these clips. Very important to get the clips in. Make sure you're delicate with the way that you clip these into place. Okay, that's looking pretty solid, and we'll just check the CPU's nice and seated. A little bit of thermal grease all over the place. We'll tidy that up, and I think we're ready for the next step. Now, lots of methods out there. I am certain you've seen hundreds, but by far this is the most applicable, if not the only CPU application method that you should follow. So take careful note. Replicate exactly what I'm doing here for optimal results. Yep, there it is. Okay, a little disproportionate on the smiley face this time, and right now we're going to use a brand new CPU spreader. This is a limited edition clear design. It's highly effective at spreading, as you're about to see, and take note, you can actually see the spreading, which is great. No, it's not just plastic material from some random package. Let's continue. So very delicate on the spreading. Now, why would you want to spread your thermal paste? Lots of different reasons, and the main one being you're actually going to get 100% coverage all over the IHS or integrated heat spreader, which you can't get by any other method. Check those YouTube clips, those short videos. They all illustrate these different methods. And really all they're proving is that you cannot use those methods. They're just insufficient. You end up with huge amounts of uncovered surface, unless you overload the CPU, in which case you may just as well add thermal paste over everything. I've seen that as well. Definitely not good. Go sparingly, work your way through as we're doing here. You'll notice every now and then we are scraping off the thermal paste. That happens when you're applying too much pressure, or if your spreader is not very good. And right now the spreader, truth be told, wasn't so well set up. It had a little bit of a lip on the end which was scraping off the thermal paste. Took me a while to realize. But nonetheless, very, very effective. Using some sort of flat material, in this case, especially designed plastic, we'll call it that. But it works really well. We get a very nice even coverage. Eventually, right now that's looking really messy, but nonetheless, you keep going. It is going to test your patience a little bit, but lots of benefits. Once you're finished with the spreading technique, you will end up with even coverage, and I would argue there's no other method that's going to compete. But definitely keep an eye out for your technique here. Too much pressure, you run into problems like that. Not enough pressure, I guess then it doesn't spread very well. So it's finding that balance. You'll see there really doesn't work well if you apply too much pressure, and difficult to gauge exactly how much, and oh, that's a lot of time. Now make sure your spreader works well. If you do notice it's beginning to scrape off the thermal paste, just add a little bit more. You'll notice it makes quite the difference there. And you could just do the blob. I think that was one of the better methods out there, but really it's important to make sure you get full coverage and that you're not wasting thermal paste, especially on these CPUs coming in here quite frequently. It's well worth making sure you've done enough. Now, once you're done, one of the key problems of the spreading technique is a little bit of an air pocket. So to get around that, you just add another smiley face in the middle. That's just perfect. Wait, why is that a frown if we turn it upside? Oh wow, did you guys see that? I felt like I saw a wink coming from that CPU. Sorry, might be a bit, oh, no, there's definitely a smiley face there. Okay, clearly that CPU is happy about these coolers. Now let's have a look at the cooler. There it is. So quick clean there with isopropyl alcohol. Trying to get the surface nice and clean, getting rid of all the oils. As you can see there, wow, that's really fast movements. Oh, there's a bit of a scratch there. So keep in mind, pick these up secondhand. They can sometimes come with a little bit of damage. In fact, if you look really carefully, you might even see the, should we call it, press marks from the original CPU. So that's okay, that's all part of the experience. Now we'll replicate that earlier smiley. I think that's pretty close. And yep, no, that looks really close, minus the wink, but that's okay. Now this is a little bit of guesswork here because I guess technically you'd want to measure out exactly where the CPU is going to go, since this particular cooler doesn't actually provide you with any markings. So try and ballpark it. I do apply thermal paste on both surfaces to ensure that there are no air gaps. We'll give a little bit of a spot on the end there, and I think we're ready to fit this particular cooler. There's our smiley face. Let's go for it. Easy. Now fitment. Very tricky on these coolers for a number of reasons. We'll work our way through those very shortly, but for now, make sure you align those screws with the motherboard mounting points. A little bit of a trick on the application. So you'll notice my left hand in this particular situation is applying a little bit of force to the cooler, and with the right hand also applying a little bit of force, but making sure that you're careful with that screwdriver. You're right in close proximity to the RAM modules. That does present a bit of risk. So you just got to work your way through. Sorry, blocking your view a little bit, but that's okay. Really tough to get a good view. The idea is, again, that crisscross pattern. Now you'll see the left hand there applying the pressure. This is actually really important in order to get these CPUs to seat. If you don't do it, it just doesn't work. Now look at the crisscross pattern. Absolutely recommend that you go for crisscross, otherwise these coolers will be near impossible to fit, I can guarantee it. So applying a little bit of pressure with the left hand really helps, because you're squaring off the screws and also making sure that the pressure is being applied evenly. I cannot stress it enough, very important, especially with these coolers, which by my eye appear to have uprated springs, and they do create quite a bit of clamping force, which is great. That's exactly what we want for good thermal dissipation. But working the way through, gradual, probably doing about 2 rotations per screw at max, cycling my way through that particular pattern. Doesn't matter so much where you start on your pattern, just make sure you follow the crisscross concept to make sure you get even spreading. Okay, I think that's nearly done. We'll round that off. Once you've done all of them, it's useful to check the tension. Thankfully on the HP equipment, particularly on these machines, they do basically peak, or the screw stops being able to thread once you reach the optimal pressure. I wish they would do that on some other coolers. So this is great. You know exactly when you've reached maximum pressure, and once I've achieved that, I just go around, check the tension on all 4 corners, and I'm going to call that seated. Now notice there were no troubles, seated the first time, and very nice fitment. Okay, we're done. Let's put the cover back on. Ah yes, those with a keen eye would have noticed we still have 1 cooler in there, but that's okay. We'll call this the halfway point, and it's a good point for some scenery. It's okay, don't forget, I knew there was another one in there. But for now, let's do a comparison. That's what we're really here for. So this is the second one that has to go in. But let's grab that stock cooler and really check these two out side by side and compare some of the differences. So you're really going to see the nice honeycomb fins, the flat fins obviously on the stock cooler. Overall, the base plate actually looks fairly chunky on the stock cooler, but we can tell there's a material difference. It appears to be aluminium on the stock cooler and likely a steel composite on the Z coolers or the 3D Vapors. One of the most striking differences is the actual mounting surface. You'll see the surface area has dramatically increased on the 3D Vapor. That really does help with heat dissipation. The stock coolers also had grooves which were not machined smoothly, so that definitely would reduce surface area quite substantially. So huge improvements there. Overall, the cores are actually relatively similar in dimensions. There are 4 heat pipes per half on the stock cooler, only 3 on the 3D Vapors, so that might be a slight reduction in surface area or dissipation. But the fins and the overall concept of the vapor chambers make up for that, no doubt. Now, another main claimed benefit is that the, I guess, honeycomb or hex fin design is meant to reduce noise. And we all know the HP Z workstations are all about reducing noise. Now, looking at these, this is all great on paper, but we still have some questions. Which one should you get? What temperature can we expect? And with these prolonged CPU endurance? Well, those are all excellent questions. I only have one way of solving this. Let's get this one fitted and do some testing. There's no other way. Okay, let's get back in there. So same thing for the second cooler. It's going to be slightly more difficult to get nice angles, so I'm going to move things around a little bit and see if I can give you as good a view as possible. Forgive my hand for blocking half the time. Let's change view. So very important on the release of these. You'll notice I'm doing gradual, couple of rotations. Then we'll go for the crisscross. Sorry, things are going to shift around a little bit. Hopefully we can keep track. Trying to find a good view. That's basically impossible unless we go in with some sort of handheld, and that just doesn't look pretty either. At least this gives us a nice bit of scenery there. You can check out the computer while we're here. Definitely check out some of the other videos if you are interested to know a bit more about this machine. Okay, working my way through, quick crisscross, nothing you haven't seen before. Okay, that's looking good. Must be getting close to being releasable. Let's give it a test. Or might still be one screw. I can feel a little bit of resistance. Okay, no, that's fine. No, definitely one screw. I told you guys there was at least one. So we'll give it a gentle nudge there. Okay, that's perfect. Yay, we're free. So same thing there, thermal paste. You can see a little bit of run out. There's that surface I spoke of. So the overall finish there is not perfectly smooth. We do have some trenches and troughs. That's going to create problems for our contact points, and you can see the run out on certain regions there as well. Definitely due for replacement. Looking at it, there's not a lot of thermal paste left there, but wow, look at that difference. Massive difference in surface area. That has to be advantageous, and hopefully we're going to see a good result on these. Now, one other thing that'd be really cool. Oh, is that a CPU? Well, if you've got a keen eye, we'll close up the machine here. Don't want to drop anything into the machine. That'd be a disaster. But we got a CPU. What's this CPU? Well, it's a related CPU. The E5-26xx V3, very capable. Spare CPU lying around. And for this one, just doing a quick check. Let's see what the footprint looks like. So you'll notice here, even on these, small portion of our CPU doesn't even make contact with metal on the stock coolers. I'm going to call that a bit of a blunder. We want more surface area. So how do we solve it? Well, you'll notice the comparison is very different when it comes to our 3D vapor cooler. There it is. So perfect match. Way overkill actually, but nonetheless this is excellent because we get complete coverage of the IHS or heat spreader, giving us the ability to do some well managed thermals there. Now you'll see the little imprints there. Those are pressure points that would make me think that the spring pressures might be quite high on these coolers to help with the thermal dissipation. Didn't find anything about that to confirm it, but that's my theory, and you can kind of see it by the imprint. Now let's quickly clean up and get ready for the next cooler. This is going quick, let's get it done. It's the same deal here, a little bit of isopropyl alcohol. Again, use a bit of safety, highly flammable. It's also a bit of an irritant, so make sure you don't get any into your eyes. That would not be advised. And same deal, try to avoid a mess, although on this one I think I'm slightly more accurate, and definite bit of cringe having to remove 5-month-old thermal paste. That definitely would have lasted me another 1.5 years minimum, but nonetheless, we'll do this in the name of science. We'll go for a fair comparison. We'll get rid of all that paste. We'll compare the coolers just before fitment, so that's the stock coolers, and these nice 3D vapors. They do look really good on the case. Really rounds off the aesthetic of our machine. Okay, I'm going to call that clean. Let me know if you see anything. Oh, was that another spot? Looks like there's a little bit of dirt here. I'll just give that a quick rub, and okay, no, I think that's okay. So really got to keep an eye on the thermal paste. It absolutely loves running off into all sorts of strange locations. Okay, I'm going to say that's perfect. Yes, absolutely. Consider subscribing if you haven't already. It's well worth it to pay for the upkeep of these smiley faces. There's so many. Now this particular one is going to give us very nice spreading. Sorry you can't see the spreading here. Hands completely obscuring the object. I may have to give it a bit of a rotation. Yeah, that's really cool looking smiley. Okay, a slightly better view. So patience is the key on the spreading method. I know it's painful and slow for those people who live fast-paced lives, but absolutely take your time for a little bit of spreading there. Yep, that was easy. Quick couple of pulls there and we're all done. Now, even if it's not perfect, don't worry, because we're covering both surfaces, it doesn't really matter. We won't have any air pockets because both surfaces will blend and we'll get perfect fusion. Now, same deal here. We'll apply our signature smiley face, avoiding air pockets, that's the goal. And let's do the next one. Quick spray. I promise this isn't recycled footage. Let's quickly clean that off so we don't have any smiley faces from someone else's fingerprints. Okay, all done. Looking for the gloss. I'm gonna say that looks pretty glossy. What do you guys think? Yeah, it's not bad. No smiley faces left over. I think that's perfect. Okay, we'll give that half a second to evaporate. Oh, wait, that might not be the right cloth. Always make sure you use the right cloth. That looks like a rather expensive cloth. We'll use a different one. Let's go for this one. That's better. Okay, next step. Thermal paste. So we have a slightly better idea of the footprint now. In fact, this particular cooler has those markings of where the previous owner's CPUs made their mark. So we're going to use that as a guide, but still going to spread well over that surface. That should be okay theoretically. Again, the CPU itself is quite large. If any of it did become, I guess, viscous or porous, it wouldn't go very far. Also, non-electrically conductive thermal paste, so we can be a bit more forgiving. Now, a couple of smileys to model off. Not quite sure. I think I need to expand the eyes a little bit to get the proportions right. Oh, no, is that becoming like an evil eye? The nose is maybe a little bit small. Very good practice here for your artistic drawing, so keep that in mind. And we just drew, oh, what is that? Okay, well, not my finest work, but that is a smiley face, right? I think. Yeah, that looks a bit weird. Yeah, nonetheless, let's keep going. We won't get distracted by that. Let's quickly round this off. Grab that smiley and I'll see you later, buddy. Let's round this off. And yes, we do not condone harming smiley faces on this channel. Absolutely not. But in the name of thermals, we will spread them if we have to. Let's keep going here. Absolutely the best thermal paste application method. It's unrivaled. I've not seen anything better out there. This is scientifically blended from multiple YouTube videos. You're welcome. Now, while we round this off, I think we're ready for fitment of these CPUs. So lots of other questions come up. What are we going to test it on? I promise some sort of data so we can verify if these cores actually work. Well, you're in for a treat. There's a few things coming up. I'm almost certain you'll be hopefully impressed with the coolers. Maybe not as impressed as you would have liked. Depends what your expectations are. Okay, I'm going to call that well spread. Look at that consistency. We'll give a couple of dabs there just to prevent those air pockets. Oh, is that a frown? No, we'll still go for the smiley. It's a very flatline smiley. But very important, that helps to eliminate any air pockets that might form from flattening out our thermal paste. Okay, there is the final view. I think we're ready. Smiley combines with smiley. Here it is. So same deal, a little bit of pressure here, very important, making sure we align all 4 of those screws. And yeah, should we cue some dramatic music? Why not? I feel like it's nice to spice this up. Now while I'm working my way through, very important again, you want to make sure that these screws grab. So it's very easy to have trouble with fitment. You want to be very sure that all 4 screws grab. And for some scenic entertainment, I asked Midjourney AI to create a bit of a portrait of myself. Apparently this is what I'll look like somewhere in the future. Don't know, you guys will have to tell me if that looks anything remotely like the current appearance. I think it doesn't look too bad. I actually quite like it. So I'll try and work towards that. The AI telling us a little bit about the future. Definitely check that out if you haven't already. The AI is available through Discord and it's able to basically produce artwork. I assume it steals the artwork from other people's artwork. No idea, but it looks really cool and I think it's really nice to play around on. Okay, let's continue. Is that cooler mounted? I really hope it is. Now, well worth going through, doing a quick check on the tensions for each of those screws. But if you do it well the first time, you should not have any problems. But we'll go through. Always nice to check your handiwork to make sure that it's all perfect. Now, as far as I can tell, these feel good. Hopefully I didn't make any errors on the installation. Now, if you did happen to have maybe one screw that didn't grab, or if you notice a problem, very easy, just unscrew all of them, crisscross method. Once you've done that, you do not want to lift off the cooler. That would be a disaster because you'll have to redo the thermal paste. But as long as you're confident with the fitment, and I think that's the final touch there. Okay, that's really good. Yeah, so that's it. I think we're ready. This is almost too easy. Z-coolers installed. The hardest part was finding them. Beautiful. Now again, very careful. Watch out for RAM modules and the motherboard with your screwdriver through this journey. Now we'll just do a quick recheck on those earlier ones, but I'm pretty confident these are ready to go. Now I think we could do maybe a little bit of cinematic B-roll just before we launch into our final testing. I'm so eager for the testing. Is this going to work well? The quick tug test. Oh, there's a bit of CPU grease there. We'll just get rid of that while we're here. Why not? And I think we're ready for some B-roll. Let's cue some B-roll. I want to see these coolers looking flashy. Question is, are they going to work well? Oh, I don't know yet. Yeah, sorry little buddy, we have to close you up to find out. But for now, let's do a little bit of scenic viewing here. So you'll notice there the GTX, no, not GTX, the GeForce RTX 3080, very capable GPU as well. And those coolers are looking right at home. So lots of questions to be answered. Yeah, sorry buddy, we do have to close this up now. We'll come back and visit you again soon. But for now, please keep those CPUs nice and cool. Now keep an eye on these wires down the bottom and let's launch into our next phase. That's right, phase 2 begins. Thermal testing, no more wasting time, let's go for it. Okay, a little bit of B-roll. It does look really cool. Look at those coolers, wow. Now, full disclaimer, the first test was on Forza. That's right, quick break-in or run-in, make your choice. So just checking what the temperatures are like, also giving that thermal paste a short chance or time to settle. The recommendation for RTX Silver 5 is around 50 to 200 hours. During that time, the paste thins out and improves its thermal conductivity, mainly due to increased or improved contact. Now, quickly speed through a little bit of racing, driving like an absolute pro, and then let's drain the CPU. That wasn't even a workout. So first one here, CINEBENCH, and we're doing R23. So what were the results here? Well, we saw lovely similar temperatures actually. The net difference there wasn't phenomenal, but as we continue our testing, we're going to see some interesting differences. Borderlands, so CPU usage, Very interesting difference there. Then we jump into our temperature and you're going to see a bit of a difference, but it's such a short benchmark that didn't really stress it. We'll throw the GPU temp in for comparison. Pause on those stats if you want to have a look at them. Next one, Kombustor CPU benchmark, or rather stress test. So let's load up these CPUs. We'll see what happens to our temperature. So far, again, not a huge difference there, but we're seeing about a 4-degree drop. That's a degree Celsius drop, slightly larger, maybe 6 degrees Fahrenheit. Lowering, so that's pretty good. We're seeing a drop. Now, no, it's only really stressing one of the CPUs, so not the most optimal test. But let's try another one while we're here. Next one there, GEEKBENCH 5 system benchmark. This is a slightly longer test, a little bit more intensive for the entire system. As we work our way through, first one there, CPU load or max usage. Fairly similar between those two runs. Launching into temperature, you'll see quite the difference there. So the overall average was slightly higher for the stock cooler, and we had a rather interesting looking curve for the 3D vapors. GPU included there, no difference expected. Now NVMe did also see a bit of a change. I did replace the adapter in between these. Check my other related video to see what that did. Thermal's still up and coming. Now while these tests are running through, the average temperature there was actually quite a bit low. That's about 10-degree drop. So definitely makes the difference when we load up the cooler. So stock coolers are great, but it looks like the 3D vapors overall do provide a nice benefit. So something between, we'll call it 4 to 10 degrees Celsius drop average, pending your workload. Really depends on the setup and what your workload is. But overall, that's well worth it, particularly for certain CPUs with high wattage. And check the data there again. Pause on the data if you want to have a look. We're just going through this really quickly so as not to bore you, but absolutely pause if you're interested and scope out the data. Otherwise this video will be like 4 hours long. My computer can barely render it already. It took 6 hours to render this video. It's intense. Okay, that was good. Hopefully you had an absolute blast. We went through, we proved the vapor coolers are beneficial. There's a nice summary of the data. Yes, this was only done after 20 hours of running. Ideally, I would wait longer. So far it's looking fine. Check the temperature comparison. On average, about 4 degrees drop between your Z coolers and the stock coolers. Not as great as I was expecting, but that's still a huge gain. It's going to keep those CPUs nice and cool. Well done. We'll call that the end of the video. I think it's time for some bonus footage. Do you guys want to see bonus footage? Let's do some bonus footage. Oh wow, what is this? Oh, that cooler looks pretty beefy. That's looking like a really nice machine. What is this? Who's building this? I have so many questions. What is that? Okay, that looks like a workstation motherboard, but that's a gaming case. Is that a GTX 970? Wow, that's archaic. I haven't seen one of those in like 10 minutes. Oh, this is fascinating. I really want to see this video. When's this coming out? I have no idea. It's taking forever. So many problems. Hopefully you'll see this very soon. I'm working hard to get this one out. Stay ready. I'll see you guys on the next one. Have a good one. Any requests, send me a message.
Phew, that was intense.